Okay, so today we're going to be learning about step functions. And so a step function, like the name sounds, looks like steps. And so when we look at these step functions, it kind of looks similar to the piecewise function that we've been learning about, where there are a bunch of different pieces of functions put together into one. But if you notice, all of our functions here are just numbers. There are no variables. So think about it. What does it look like when I have just a number for my function? So like the first one is really y equals -2. So what does it look like on the graph when y is -2? Well, that would look like this long horizontal line. Now don't draw this just yet because that's actually not what our graph will look like. Because if you remember from piecewise, we have this domain restriction. So what this restriction does is it tells me where the y equals -2 line starts and stops. So really it starts and stops. It starts at -3 and it stops when x is 1. So I could go ahead to where we've got to -3 on the x, right? That's where it starts and it stops when x equals 1. So it is just this little piece of that graph right there. And then we also need to be aware of the endpoints just like we were before. So let me go through how I would actually graph this if I was approaching the problem from start to finish. So I see the first line is y equals -2. And now I want to look at the inequality. Notice it says -3 is less than or equal to x. That or equal to means x is allowed to equal 3 here. So -3. So -3 is going to have a closed circle because it is included in this inequality. Then the inequality goes on to say that x is less than 1. Notice there it does not say or equal to. And so therefore at 1 we will have an open circle, because 1 is not included in this inequality. So I'm going to start at x equals -3, y equals -2, and put a closed circle. And then I'm going to go to where x equals 1, y equals -2, and place an open circle. Connect your two dots, and there is your first step. Then I'm going to repeat for the next line of this step function. So here I've got y equals 2. If 1 is less than or equal to x is less than 3. The first part, 1 is less than or equal to x, means that at 1 I have a closed circle because x is allowed to equal 1. On the other side, it says x is less than 3. That means it's going to be an open circle at 3 because x is not allowed to equal 3. Now I'm going to plot these points. If it helps you, you can think of this as the x and this is the y of an ordered pair. So we have a closed point at 1, 2, and we'll have an open point at 3, 2. So I go ahead and plot those. Closed point at 1, 2, and an open point at 3, 2. Connect those two dots. There is our second step. And continue on. So in the third line, I have y equals 6 if 3 is less than or equal to x is less than 8. So we have 3 is less than or equal to x. So this one will be closed. And then x is less than 8 will be open. If it helps you, our closed point, the ordered pair, is going to be at x is 3 and y is 6. And the open point will be at x is 8 and y is, again, 6. So you don't have to write these points, but if they help you, then you can keep making them. And there's our graph. for that section. The very last one is y equals 10 if x is greater than or equal to 8. So notice this one only has one endpoint. Starting there, we have a closed circle at 8 because it's or equal to 8. So we're going to start with our closed point at x equals 8, y equals 10. Now notice this is for all x's greater than or equal to 8. So that means that there's nothing that stops it from continuing on forever. So this one is actually going to get a line with an arrow because it does not have that second endpoint. It starts at 8 and it continues for all x's greater than 8. So that's our step function. Now the steps are not always equal or the same distances apart, but they do look like a bunch of little horizontal steps. Let's look at one more example together. So in this next one, I'm going to start with the first line again. I have y equals -6. For x is less than or equal to -8. I notice that or equal to, which tells me this will be closed. So my x is -8, my y is -6. I'm going to plot this first closed circle. Again, if it helps you remember, x comes from right here and y comes from right here. And this is all x's that are less than or equal to -8. So that would be all the x's to the left of -8. If it helps you, notice the less than symbol is already like an arrow pointing left. That could be a helpful tip on which direction your arrow should go. So this is all of the x's less than -8, which would be the numbers to the left. The next line is y equals -3. If -8 is less than x, that's an open circle. And x is less than or equal to -2. That's a closed circle. So my first point is open at -8, -3. And my second point is closed at -2, -3. So I will plot those points. -8, -3 is open. -2, -3 is closed. Draw the next step. The third line is y equals 0. If -2 is less than x, should be open because I'm not allowed to equal -2. And if x is less than or equal to 1, so closed. So my first point is the open one at -2, 0. And then we have a closed point at 1, 0. So I'm going to plot my points. Remember, a lot of this works just like the piecewise. So another thing you won't see is two closed endpoints, one on top of the other. Because remember, then this would not pass the vertical line test. So that's a good way to check your work as you're going through these problems. The last line now is y equals 3 if x is greater than 1. Notice it's simply greater, so this is open. My open point is at 1, 3. And after 1, 3, it's for all x's greater than 1. So it never stops. It continues to increase along this horizontal line.